Monte Carlo Simulation, Chapter 14. Let me give you some background. Monte Carlo is a place in France and is very famous for having a casino there, which many people around the world travel to Monte Carlo because it's a beautiful place. So what's got to do with what we're going to look at today? Well, in the 1940s, a group of scientists working on the Manhattan Project were developing nuclear weapons. And they wanted to figure out things such as the distance a neutron would travel in a substance before it collided with an atomic nucleus, and how much energy would be given off when that collision takes place. Now, obviously, it was dangerous, so they didn't want to keep on doing physical experiments. So they wanted to get some sort of simulation to get some idea of what was likely to happen. So because there was uncertainty involved, it wasn't the fixed result that they were expecting. There was some uncertainty involved, and they wanted to figure out the range of possible things that may actually occur. So Monte Carlo, how does that come up now? How do we marry those ideas together? Well, basically, it was a top secret research project, and so they needed a name for it, a secret name for it. And one of the professors working on the project had an uncle that had lost the family fortune at the casino in Monte Carlo. As you know, casinos, you can lose money or you can make money. It's uncertain. There's uncertainty actually attached to this. So they decided to call it the Monte Carlo Project and Monte Carlo Simulation. That's where the name actually comes from, because it's to do with uncertainty. And they were looking at the uncertainty of nuclear reactions, but the code name for it was Monte Carlo because casinos also have uncertainty. So that's where that comes from. So Monte Carlo simulation tries to pick up uncertainty, and you do see that we have uncertainty in everything that happens in life. Whatever we do in life has uncertainty, whether it's business, whether it's government, or in our personal lives. There's always uncertainty. A Monte Carlo simulation is used to evaluate the impact of the uncertainty on a decision we make. And it's being used successfully in financial applications, marketing applications, and management applications too. So how does it actually work? What we've looked at so far is things like, I want to figure out what my investment's going to be worth if I invest money on the stock market. And up until now, we've said things like, well, I think that I'm actually going to make a return of 5% if I invest on the stock market. It's uncertain though. But if I just put in 5% into a model and run it to see what my return is going to be, that would be called a deterministic model. But I'm just running in one thing, one item. But I can actually pick up the uncertainty by using a probability for the return I think I'm going to get. So I could say the return on a particular investment, I think is going to be 5%, but I think it may be as much as 7% and as low as 3%. And is equally likely to give me a value between 3 and 7%. So now I've changed the input to my model from a fixed number of 5% to a whole range of possible values. And I can now pick random values between 3 and 5%, input them into my model, see what the outcome's going to be, and then I can pick another random value between 3 and 5%, put it into my model, see what the outcome's going to be, and I can generate thousands or millions of outcomes to my investment. And once I see all the outcomes, I may well see a pattern to them, and I've got a better idea as to what's going to happen in the future. And looking at the pattern, I can look at the likelihood of the different things that may occur in the future. So this is what it says on this PowerPoint. It says, the probability distribution, we actually come up with here, it says that it comes up with a range of possible values and also the relative likelihood of the various outcomes. So it looks at a range of possible values plus the likelihood, the chances lots of outcomes where we begin to see the trend. A simulation model extends the spreadsheet modeling approach, and it replaces the use of a single value, like 5%, for parameters, with a probability distribution of values. So it's going to replace the 5% by a whole range of possible values. And just a couple more notes. Parameters that are not known with a high degree of certainty are called random or uncertain. And the values for random variables are randomly generated from the specified probability distributions. And simulations help us to make decisions and recommendations for the controllable input. So once I get all my output for my investments and I've got all the possible scenarios that may come, I've run my model 1,000 times and I've seen what the possible outcomes are going to be, then I can decide on what stocks and shares I can actually invest in. So there will be an example that we're going to run, and there's a video for it, and that is going to, actually has a model run 1,000 times in Excel. Moving on. So we're going to look at risk analysis for this company, and we're going to look at all these things that you see here. And so we've got the base case scenario, worst case, best case, and then we're going to do a spreadsheet model. So let's look at what these things are. So a lot of the time, decision makers, they're all interested in making profits, but a lot of the time they're more worried about the risk of an undesirable outcome. So they want to analyze that. So we've got an example here. We're going to analyze the risk, and it's for a company making medical devices. And we're told that this company, Sanotronics, has got this new medical device, and the selling price will be P, and the first year admin costs are going to be CA, and the direct labor costs, I think it says CI there, but maybe it should be CL for labor costs. And the parts cost P, and the demand is what they're going to sell in a year. So I could actually come up with a formula for profit, because what we are interested in is the profit for the first year. And the profit for the first year, I can tell you it's going to be equal to, well, each unit we're going to sell for P dollars. And for each unit, there's going to be a labor cost of CL. And then there's going to be a parts cost of CP, so per unit. So these are all per unit costs. So this is how much we make per unit. And if we sell the units, if that's the demand and we sell them, that's going to be the amount of money that we've got coming in. But that's not all profit. We have to take out the cost that we have for first year admin and advertising. So this is actually going to be the formula for profit. So what they're telling us here, they're telling us that they're fairly certain, or they're highly certain, in fact, that the selling price will be $249 per unit, and the first year's admin and advertising costs are going to be $1 million. So two of the items we saw on the previous page, this one is $249, and they're fairly certain about that. And this one over here is going to be $1 million. So what else do we know? Presumably the other items, the labor cost, the parts cost, and the demand are going to be uncertain. Let's see. So it says, let's work out a base case for the profit. And by the way, a base case is the most likely outcome. Okay, so base case, don't forget that it's going to be the most likely outcome. The most likely outcome. Okay, it's the most likely outcome. So this is the same formula we had on the previous page. They put in the 249 and they put in the $1 million. So the other costs, the labor cost, the parts cost, and the demand seem to be uncertain. And we're told there that they are uncertain, but for the base case scenario, the most likely outcome, they're giving us values for them of $45, $90, and 15,000 units. So we've got the labor cost coming through at $45, and the parts cost coming through at $90, and they're going to sell 15,000 units. So what you can actually do is put those values into the formula. So we put the 45, the 90, and the 15,000, and that gives us a value of 710,000 of profit. So the most likely base case scenario predicts that this company will make $710,000. That's the most likely outcome. Now, we can actually, let's look at the next slide and see what it says. Now, it says that Senatronics is aware that there is a degree of uncertainty with those costs. So it wants to run a what-if analysis. It's not saying, okay, this is the base case, this is what I most likely think is going to happen. We're worried about risk. We could make more money, we could make less money. So we actually want to run a what-if analysis, try different values in for the items we're uncertain about. We're uncertain about the labor costs, the part costs, and the demand. So we can actually run different scenarios. And there's two different scenarios we're going to run, a worst case and a best case, because we've already got the most likely. So let's see how that pans out. The worst case scenario, when it comes to your costs, is that your costs are going to be high. And when it comes to demand, is that your demand's going to be low. So a worst case scenario, you can see that the labor costs are more than they were before. So the labor costs before, on the previous slide, if you look back, were only $45. Now they've gone up to $47 in a worst case scenario. The parts costs have also gone up, so my costs are increasing. They increased from 90 in the most likely case to 100 now. And the demand, oh gosh, the demand was 15,000. The demand's now gone down to 15. It's gone down from 15,000 to 0. So that's not good. But this is the worst case scenario. So in a worst case scenario, we're going to put in $47 for our labor costs. We're going to put in $100 for our parts costs. Unfortunately, the demand is 0. So what happens here is that we're actually going to make a loss. And it looks like this figure may be a little bit wrong. That should actually be a negative. That should be minus 1 million. We're going to actually make a loss of $1 million. So the worst case scenario is not very good. And so let's look at a best case. So what's the best case? The best case scenario is our labor costs are lower. You can see they've gone down. Our parts costs are lower. And that our demand is higher. So if we put those items, there you go. We put these items into the formula for profit. Our profit is going to be $2.78 million. So the thing is that we can see by looking at these three different scenarios that there's a range of different outcomes that may occur. So the base case, the most likely case, is 710,000, but we're not by any means certain that we're going to get that. The problem with just doing a simple what-if analysis and working out these three different scenarios is they don't actually give us any indication of the likelihood of the various profit or loss values. How likely is it that the outcome is going to be 710,000? We don't know. How likely is it that I'm going to make a loss? I don't know. And that is a problem when you use this approach where you just test one thing at a time. I've actually done these calculations using a spreadsheet. Let me show you how to do that. That's what it actually says here. Let's actually look at a spreadsheet. So let's put these values in. So this is for Senatronics. The parameters are the selling price per unit is $249. The admin costs are $1 million. The direct labor costs per unit are $45 on my base case. The parts cost per unit are $90, and the demand is 15,000. So what's the actual profit going to be? And the profit is going to be equal to, well, how much do I make on any part? I'm going to get $249 for one part, and I will have to subtract the labor costs, and then I'm going to have to subtract the cost per unit, the parts cost per unit, and then how many units I'm going to sell, what's demanded, hopefully I'm going to sell them all, is going to be 15,000. And from that, I'm going to have to subtract the admin costs. So this is just a way that you can calculate the original base case most likely scenario. And if you want, you can do your what-if analysis by going into here and changing these values. I can change this. These two are fairly set. They were certain about these two values, but they weren't so certain about these values in here. These were just like chance values. They're not 100% sure. So I could change that to $50. And I could change this to $92. And I could change the demand to 12,000 units. And you can see as I change everything, the profit changes. So this is a very useful way of actually setting up our model. And we're going to actually develop this model in a moment. So even though this is maybe a neat way of actually coming up with a potential profit, it's not particularly efficient way of actually doing it. So let's have a look at what the PowerPoint says. So that's the what if analysis, and this is what we actually came up with. That's the sheet I just showed you a couple of seconds ago. And so this is not in a particularly efficient way for me to manually go in and update that model. So Sanotronics, what they've done is they've actually gone on to identify probability distributions for the distributions of direct labor costs, parts cost, and first year's demand. So let's see what they came up with. So this is what they came up with. They said that the labor cost will look somewhat like this. So they said that the labor cost may be $43, and the chances that that happens is 10%. They may be $44, and the chances that that happens is like 20%. They could be $45, and that's going to be a 40% chance of that happening. It could be $46, and that could be a 20%. That will be a 20% chance. And they could be $47 with a 10% chance. So how can I actually use that? So what I'm going to do is give you an indication of how this is going to be used in Excel. So I'm going to give you a little background before you actually see how the model is set up. So one of these is going, we're assuming that one of these values is definitely going to occur. That's an assumption that we're making. So there's a 100% chance that we're going to get one of those values. So the value, there's going to be a 100% chance. But start at 0, I'm going to go all the way to 100 to the right, all the way to 100. Okay. And so then what I'm going to do is I'm going to say, okay, it may be a $43 labor cost. And there's a 10% chance that that happens. So this area has to be 10%. Or it could be $44. But there's a bigger chance of it being $44. There's a 20% chance. So I'm going to try and make this double the width. So that's going to be, this width in here is going to be 20%. So if this is already 10%, if this is 10% of the way along, this is 20, this is going to be at to 30% along here. And then the charge could also be $45, but there's a much bigger chance that it's $45. There is a 40% chance. So it's going to be 40% of the way along. So that's going to take me up to 70% of the way along. Or it could be $46. And the chances that it's $46 are 20%. So from 70, another 20% of the way along is going to take me up to 90%. Now, it could also be $47, but there's only a 10% chance, and that's going to take me to 100%. So how's that going to help me? Well, if we consider this number line that I've drawn goes from 0 to 1 or 0 to 100%, I can now say this. I can say that if I can randomly generate a number that falls somewhere on this line between 0 and 1, that if the number falls between 0 and 0.1, which is 10% of the way along, then I can say that my labor costs are going to be $43. So if I generate a random number and my random number falls in this range in here, then I can say that that the labor cost is going to be $43. And I can also say that the labor cost will be $44, and that's if I get a value that falls in this range in here. So if I get a value that falls between 0.1 through 0.3, and then I can say that the labor cost will be $45 if I get a value that falls in this range in here. So I'm going to say that the labor charge is going to be $45, and I'm writing over stuff. But if I get a value that falls between 0.3 and 0.7, so between 0.3 0.7, then I'm going to say that my labor charge is 45. So I'm not sure how much sense that makes right now, but in a moment after this video, there's another video that's going to use this. So I just wanted to give you some background on it. There's a little bit of an explanation here, which you can look at. It's basically trying to say the same thing that I just said. So moving on from that, we've got the parts cost, and this is what the parts cost is. The parts cost is somewhere between 80, minimum of 80, maximum of 100, and it's uniform. There's equally likely to be one of those values. So the parts cost is going to be $80 plus something, and that something is between 0 and 20. So if it's 0, then it means our part cost is 100, is exactly 0. And if that something happens to be 20, then our parts cost is 100. But it can be anything between 0 and 20. So it could be, say, for example, 10. That something could be 10. So it's going to be 80 plus 10 equals 90. So there's an equal chance of the costs here being, the parts cost being anywhere between 80 and 100. And it tries to have a little bit of an explanation there, which you can look at on your PowerPoints. And then finally, it's telling us that the demand will be normally distributed, and it will have an expected value or a mean value of 15,000 units and a standard deviation of 4,500 units. So a couple of things I want to point out before we actually get into the example is a couple of functions in Excel. Let's go over to our Excel. One of the functions is the random number generator, and that's just going to be equal RAND, open and close parentheses, nothing inside, press enter. That will generate a random value between 0 and 1. If I press F9 on my keyboard, it will generate a new random number. In fact, every time I press enter, move around my keyboard, that number is likely to change. So that's going to be used in the next video that you're going to watch. And the next video you're going to watch is actually made by the publisher. It's a very good video. And they will be using this. Another thing that I want to draw your attention to, there's another random number generator, and it's called rand between. So sometimes you want to generate a random value between 2 points. So supposing I wanted to generate a random number between 1 and 10. So the bottom is 1 and the top is 10. And that's going to just generate a random number between 1 and 10. And every time I press F9, it's going to keep on generating a new random number between 1 and 10. And they're all equally likely between 1 and 10. So what I would like you to do now is watch the next video, because the next video is going to take you through the rest of the PowerPoints. The rest of the PowerPoints, there are 2 examples, and it's going to take you all the way through those 2 examples. Now, only the first example is relevant. So you only have to go through the next video, which is the first of the 2 examples, and watch it. There's also a second video, but you don't have to watch that for the second example. You just need to actually get this particular example out. That's all that's going to be tested on your exam. The following example is the simulation model for the land shark, the one after the one after this one. So the one that is optional is called Simulation Modeling for Land Shark Inc. Now, it's in your PowerPoints. I've left it in there because some of you will be interested in it. And I've also got the Excel spreadsheet and all the data that you need for it. And I've also got a video for it, but that is optional. So the second video after this one is optional. That's the one on Shark Inc., Modeling for Land Shark Inc. But this particular one and the one directly after this one, you should watch.